Hello, today we are going to solve the question number 59 from IIT JAM 2020 Mathematical Statistics. This is a question from numerical answer type questions. Uh, in this type of question, we need to find or we need to evaluate a numerical answer. And by the question, we need to round off to two decimal places. So let's see what is in this question. Let x1 is equals to 1 and x2 equals to 4 be the data on a random sample of size 2 from a Poincare theta distribution where theta is belongs to 0 to infinity. Let psi theta be the uniformly minimum variance unbiased estimator of psi theta. Psi hat be the uniformly minimum variance unbiased estimator of psi theta, which is equals to k equals to 4 to infinity e to the power minus theta to the power k divided by k factorial based on the given data. Now we need to find what is the value of psi hat. Okay, so let's try to solve this. As we know, the PMF of Poincare theta is equals to e to the power minus theta to the power x divided by x factorial, where x is equals to 0 to infinity. Now by the question, psi theta is equals to sum over 4 to infinity e to the power minus theta to the power k divided by k factorial. Hence we can say that this is nothing but probability of capital X is greater than equals to 4, where x is following Poincare theta. Okay, now define one function hx1 which is 1 when x1 is 4 to infinity, 0 otherwise. Okay, therefore the expected value of hx1 is nothing but probability of x1 greater than equals to 4 or psi theta. Now we already know that sum over xi I equals to 1 to 2 is a complete sufficient statistic for Poisson distribution. Okay, therefore we have an unbiased estimator hx1 and sum over xi is a complete sufficient statistic. Therefore by Lemon-Scheffé theorem, by Lemon-Scheffé's theorem, expectation of hx1 given sum over xi 1 to 2 is an UMVUE of psi theta. Okay, therefore psi hat is equals to expectation of hx1 given sum over xi. Now we just need to find this expectation. As we know that hx1 takes 1 when x1 is 4 or greater than 4 and 0 otherwise. But by the question, we have two samples, x1 equals to 1 and x2 equals to 4. So for the first value, there is zero value for each x1. Hence, only for the next value, x2 equals to 4, we get 1 corresponding to each x1. Hence, the expectation reduces to probability of x1 is equals to 4, given that x1 plus x2 is equals to 5, or it may be x1 is equals to 5, given that x1 plus x2 equals to 5. Okay. Now, if we calculate the first probability, we get x1 equals to 4 multiplied by probability x2 is equals to 1 whole divided by probability x1 plus x2 is equals to 5. And if we calculate the next probability, we get x1 equals to 5, probability x2 is equals to 0 divided by probability x1 plus x2 is equals to 5. Now, all these random variables are Poisson theta, therefore uh, we just need to replace this probability by their corresponding values. As we already know the PMF of Poisson, therefore probability x1 is equals to 4 is nothing but e to the power minus theta, theta to the power 4 divided by 4 factorial. Probability x2 equals to 1 means e to the power minus theta, theta, and here we get e to the power minus 2 theta, as x1 and x2 both are Poisson theta, therefore x1 plus x2 is Poisson 2 theta, therefore we get e to the power minus 2 theta whole to the power 5 divided by 5 factorial, plus e to the power minus theta, theta to the power 5 divided by 5 factorial into e to the power minus theta, and here we get e to the power minus 2 theta whole to the power 5 divided by 5 factorial. So here e to the power minus theta cancels out and we just get 1 by 4 factorial multiplied by 5 factorial divided by 2 to the power 5, and here we get 1 by 5 factorial multiplied by 5 factorial divided by 2 to the power 5. Okay, therefore here we get 5 factorial divided by 4 factorial into 1 by 32, that means 5 by 32, and this is nothing but 1 by 32, hence 6 by 32, which reduces to 0.1875, or we can write 0.19. So 0.19 is our required answer. Okay, so we have solved this problem, and that's all for today. Thank you very much.